So, Sarah, I went to class today, and I learned about Hardy-Weinberg and Hardy-Weinberg equilibrium.
Okay.
So,
do you have any questions about it?
I mean, I understand the 5 requirements for a Hardy-Weinberg, and those are very large population size, no natural selection, no mutation, like an X-Men.
Oh, yeah.
Yeah. No gene flow, and random mating. We don't do this because we study for our finals.
This is true. Very true.
Very true. But the only thing I don't get about Hardy-Weinberg is the problems, the math problems. You know I'm not very good with math. You know.
I can understand that. But it's really not that bad.
Really?
No.
Because, I mean, I'm sure that Godfrey Hardy didn't make it that bad.
Neither did Wilhelm Weinberg.
Weren't they a physicist and a mathematician?
Exactly.
How cool. Both different realms of science come together for biology of all things.
Go figure.
So, how would you do a Hardy-Weinberg problem, math problem?
You need to know a few things first.
Mm-hmm.
You know, you have to know that it's your zero starting point. There's absolutely nothing going on there.
And we know that this can be used in like police investigations and finding out about inbreeding and stuff like that. So it's really useful, even though all these different 5 requirements don't really happen that much.
Yeah.
But guess what?
What?
I went last summer to an island, a deserted island called Hardy-Weinberg Island.
Really?
And they had a Hardy-Weinberg equilibrium. That means they had all 5 requirements and everything. And I took that because I was like, I'm going to college, majoring in biology. Come on.
I got you, girl. Totally understand.
So what I found out was 45% of the people on this island had the dominant allele for curly hair, like your hair.
Yeah.
And so what I wanted to find is how many homozygotes for the recessive allele. Like if they had, say the trait was big B, it would be little b, little b. But I knew already how many have just big B, not homozygous big B.
Oh.
So it can be heterozygous and the homozygous. That's how the amount of people, and that's how I got the 45%. How would I do this?
Well, you want to know your formulas first. So the first one we have, because you have found the 45 degrees, would be the P plus Q equaling 1. Because with your 45 degrees, you can get P right away. Because you can turn that percentage into 0.45.
And you would do this by dividing 45 divided by 100. It's good that we get to use a calculator on the test.
Exactly. So, but then after that, you need to find your Q. Because as I said, you have P plus Q equals 1. So, you can just take your P and subtract, to find your Q, you do 1 minus your P, which is 0.45, to get 0.55.
God.
But you're not done there.
Okay.
Because then you need to go on and you need to use this formula.
And that shows the homozygous dominant, the homozygous recessive, and the heterozygous.
Exactly.
P squared would be the homozygous dominant, the amount that is in the population.
Exactly.
2PQ would be the heterozygous, and how many times it would be in the population. And Q squared, or the percentage. Q squared would be the recessive homozygous.
Exactly.
And the amount in the population.
So all you really need to do to find your Q squared is take this 0.45 and square it.
0.55 you mean?
Yeah, 0.55.
Yeah.
I'm sorry. So you take your 0.55 and you square it and you get your Q squared.
Yeah.
Which gives you 0.3025.
Which can round up to 0.303 because in science you usually round to about third decimal.
Yes, but that's only when you're making it a percentage.
Yeah.
Otherwise, you can leave it like this and it's fine.
Okay. So that means that 30.3% are homozygous recessive. That means 30.3% of the people on that island will have straight hair.
Exactly.
And that's basically kind of what I saw when I was there. I took some pictures. You should see them. I put them in my scrapbook and stuff.
Oh.
So, that means, say, if 1,500 people were on that island, and 30.3% of them have the recessive, homozygous recessive alleles, and that's their genotype, that means that 454.5 people have straight hair.
Wow.
I don't know how you get a half of a person, but
maybe they have wavy hair.
That might, but that wouldn't that be kind of like a heterozygote?
True.
Because maybe that's a part of like codominance and non-Mendelian inheritance. I think it's inheritance or something genetics. I learned that last test, but I studied credit that. It's not cumulative. It's not a cumulative final. But either way, it's kind of cool. So I see how you can find out what amount of people have certain things and how police use this. Cool. Hardy-Weinberg made pretty cool.
Yeah.
They're a good
pair.
Yeah.